So hey everyone, so today we're going to look at another problem from LeetCode, which is to find how long it would take for the oranges to get rotten. This is a pretty interesting problem because you have food in it, right? So whenever food is involved with the problem, it's always pretty exciting to solve it. So just to give you an overview of what this problem is, we are basically provided with a two-dimensional array, and the two-dimensional array will have three values in them. It can have zeros, it can have ones, or it can have two. And zeros, uh, in a sense of this problem, would represent an empty cell. So you have all these pattern, right? So you have this two-dimensional array. I'm gonna open up. So you have this two-dimensional array, and you have zeros, and you have ones, and you have twos. So zeros means that there are no oranges at this location. One would mean that there are normal oranges in this location, meaning fresh oranges. And two would signify that the orange at this location is rotten. And we're supposed to find how long it'll take for this entire batch of oranges to get rotten. So there's two possible answers for this problem, right? One, you should return the number of units of time that it will take for the entire batch of oranges to get rotten, or if it's even possible to get rotten or not, right? So there might be cases where rotten tomatoes could not reach a fresh tomato, right? So for example, here we have two, and a Rotten Tomatoes two would if Rotten Tomatoes is close, it's adjacent to fresh tomatoes, the fresh tomatoes would get rotten as well. So we have two here, and when we do an iteration, we check if the adjacents. We're not going to check for diagonal adjacency. We're just going to check for left and top bottom adjacencies, and if at all there's a fresh adjacent tomatoes to the rotten one, the fresh tomato would get rotten as well. And so likewise, what would happen is this two would make this one become rotten, and then this one become rotten as well. And then we would go over to the next element, and we would see, hey, this is two, and we have two adjacent fresh oranges, so this would become two as well. This would get rotten as well, and then we would go here. We don't have any fresh tomatoes that's adjacent to here. We would go to the next. We would see if there's any fresh tomatoes. There's no fresh tomatoes adjacent to this. Go to the next, and then we would see if there's any fresh tomatoes. So right now we have a fresh tomato here, so this would get rotten as well. And then we would go to the next, and this is empty, so there's no tomatoes here at all. So we would go to the next. There's no tomato here at all. We would go to the next. This is rotten, and we would see if there's any fresh tomatoes that's adjacent to here, and we see that one is adjacent. There's a fresh tomato on the right, so we would change it to two as well. So once we do this iteration, we would do another iteration of the two-dimensional array to see if there's any fresh tomatoes that's left out. If there's any fresh tomatoes left out, that means that it would mean that there's no way of getting the entire batch of oranges. I meant to say tomatoes, but I think it keeps switching over. But it's supposed to be oranges, but uh, being that the entire batch would never get rotten. So if we're not able to get the entire batch rotten, we would just send -1. If we're able to get the entire batch rotten, we would send the number of iterations, or in this case, the number of units of time that it would take for the entire batch of oranges to get rotten, right? So there's an easy way to solve this problem. We would be making use of a queue, and the way that we would solve this problem is that once we get the two-dimensional array, we would do an initial iteration over the two-dimensional array, and we would add all these two to the queue. So to add it to the queue, we're going to store two details. So we would store the time frame that we're in right now. So the class node will have time frame, and then another two integer variables, which is an x and y, which denotes the position that the rotten oranges are in. So in this case, it's 0 and 0 here, and then another. I guess this is only rotten oranges, right? So we would do an iteration. We would add this to the queue. So once we do that, our queue would look something like this. So the time would be 0 because this is like the first um, iteration that we're doing, and then the location is 0, 0, and this is the only element in the queue, right? We have, and once we're done with that, we would do another while iteration, uh, and then we would iterate until the queue becomes empty. So when we iterate through the queue, we would remove the elements from the queue, and then we would check if this element at this position has any adjacent oranges. So we would compare this and this and check if there's any fresh adjacent oranges adjacent to the rotten orange, right? So we have two. And what we would do is we would add these two elements to the queue as well. So we have one and one. And the way that we add is we would put 0 in it because it's like the first iteration that we're doing. Um, Okay, we would not add 0 to it. What we would do is that we would add +1 to this time frame here. So we have 0 and then we do a +1 to this time frame and then we would add it to here. So in this case, it will not be 0, it will be 1. And then we would add the location as well. So we have 0, 1. And then another node within the queue, which is again, we would add +1 to it and then we would 1 here and then the location of the node, which is 1, 0. Right. And then once we've done with it, we will go over to the next. We've removed this, right? So we will go over to the next node in the queue, and then we will remove this, and then we will see that hey, this is like the Rotten Tomatoes right now. So we would see its adjacent as well. So we would see this and this, and then we would add the fresh tomatoes to the list to the queue here. So we would add this one, and in this case we have already one, and we would need to add one again to this, and then we would get two. So that's the basic idea here, and then we would add the location as well. So in this case it would be 0, 2, and then we would add another node which would be 2, this 2 here, and then this would be, what is this, 1, 1, right? And then we would remove this, and then we would go over to the next one, which is this Rotten Tomatoes over here. So we would see if it has any adjacent fresh tomatoes, and it doesn't have any adjacent fresh tomatoes, so we're just going to remove them, and then we will go over to the next one, which is 0, 2, 1 here, and we see if there's any fresh tomatoes that's adjacent to this one. Unfortunately, we don't have any fresh tomatoes because we've already added this one to the node here, 1, 1. So we'll go over to the next. Then we would get this, and then we would see if there's any fresh adjacent oranges. So we have one here, so we're going to add this to the queue. So the way that we would add is that we would do a +1 to this 3, and then we would add the address of this location. So we have 2, 1, right? So 2, 1, and then we would change this to 2. And I don't think we have anything adjacent to this one, so 1, 1. So I'm just going to remove this, and then we're going to pick this one from the queue, and then we're going to see if there's any fresh tomatoes adjacent to this location. So we do see that there's an adjacent fresh. I keep interchanging tomatoes and oranges, but it's pretty much the same. We do see there's an adjacent fruit here, so we would end up adding this to the queue. So what we would do is that we would do a +1 for this 3, and then we would do 4, and then we would add this address, so which is basically 2, 2, right? Is it? Yeah, it's 2, 2, and then we would add this to the queue, and then we would remove it, and then we would go over to here, and then at this point we've arrived at the last, right? We would see if there's any adjacent fresh fruits to this node. If there's nothing here, right? So we would end up removing this from the queue as well. So once we've done all this, the queue is empty, so we would break out of the loop, and we would do another iteration to see if there's any other one, meaning fresh vegetables that's still left out of the array. If we did have one left out, we would return -1 because we were not able to rot all the fruits or the vegetables, I guess. And but if we didn't have one, we would just return the last time that we have here, so which is 4. This would be the number of units of time that will take the whole batch of oranges to get rotten, right? So if you go back, this is what we get as an output. This is the exact example that I used, and this is the code for solving this problem. You have a queue, and then you're doing the initial iteration to add all the rotten oranges to the queue, and then you're creating a while loop until the queue is empty, and then you're getting the rotten tomatoes, and then you're checking all the adjacency for all the fresh, if there's any fresh oranges. So if there is any fresh oranges, we're creating a new node and then adding it to the queue, right? And then we're making it rotten. We're doing this the same for all the edges at the top, the bottom, the left, and the right, and then we do the same thing till the queue is empty. Once we found that the queue is empty, we would just do an iteration to the two-dimensional array again, try to find and see if there's any one, meaning if there's any fresh oranges. If there is, we're going to return -1, meaning that we were not able to rot all the oranges. And then at the end, if there's no fresh oranges, we're just going to return the last stage, meaning the last how many minutes of time it took for the entire batch of oranges to get rotten, right? So that's kind of the way that you solve this problem. Uh, yeah. So thanks, guys. Thanks for listening. See you again tomorrow with a new problem.